Hey class, this video is going to help you with electron configurations, how to write them, how to draw them in their orbital diagrams, and also how to get familiar with this homework assignment that's listed up on Canvas. Now, luckily for you, we're not going to get super in-depth on this. For you advanced students, you need to know how to do this for AP and college chemistry. So I highly suggest studying and practicing a lot. On level, you're going to have to do this as well, but only for our quiz and moving forward. Now, the first thing you have to know before you can do any kind of electron configurations, you have to know the periodic table, and you have to know what sublevels are what. Now, I'm going to highlight these real quick for you. In the red, that's the S sublevel, and that includes helium. Helium is technically right there. The blue, that's the P sublevel. You gotta have a marker that works. Apparently green is not my fan. The purple is the D sublevel, and then the F, way down at the bottom, the lanthanides and actinides, which for this video, we're not gonna worry about because that doesn't come into play until later. So mainly the S, P, and D sublevels. Now that we have that, let's go back to our worksheet. Erase this really quick. All right. Now the first part of this is drawing the electron structure or the electron diagram. You might see this called like a spin diagram or electron notations, many different types of things. Or an orbital diagram or orbital notation. It says fill in the box with the arrows representing electrons, for the correct state of this ground element. Now this one says for O, that's oxygen. Oxygen, atomic number 8 has 8 electrons. So we're going to go back. We're going to start with the lowest energy level first. And we're going to draw 2 electrons. 1, 2. They have to have opposite spin, as we've talked about. That's 2. We're going to move up to the 2s. We're going to have 2 there as well. That's 4. Oxygen has 8. Now when we get to 2p, we have to insert 1 electron in each energy box before we can proceed to 2. So we got 5, 6, 7, then come back, and 8. How many valence electrons do you say? Well, the 1 energy level is completely full. The 2, we've got 6 valence electrons. So when it says to draw the Lewis dot diagram, as we saw in the other video, we're just going to go 1, 2, 3, 4, 5, 6. Now we want to write out this electron configuration. And again, I know this is a lot to take in at once, but it's just kind of a quick overview. You start off with your lowest energy level, 1s. How many electrons you have? 2. Go to your next energy level, 2s, 2. Next energy level, 2p, 1, 2, 3, 4. So that would be our electron configuration for oxygen. 1s2, 2s2, 2p4. Let's try a different one. All right, let's look at aluminum. First up, aluminum's got 13 protons, meaning 13 electrons in a ground state. So start back here with 1s. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we ended in 3p1. The 3 stands for the energy level or the period. So period 3. This is sublevel P, remember, and it's the first element, 3p1. That's where that comes from. Aluminum has 3 valence electrons. So we got 1, 2, 3. And then to write out this electron configuration, we're simply going to go 1s, 2, 2s, 2. 2p is full, but it can hold 6, 2p, 6, 3s, 2, and then on to 3p1. A little bit more complex, not too bad. We still haven't even gotten into D yet. Never more than F, which is down in lanthanides and actinides. So you want to fill up the diagram starting from the lowest to the highest energy. And then when you write it, same thing. Start with the lowest, go all the way. Don't skip any sublevels or any periods. Go straight in order. All right, let's check out another one. Calcium. Let's see. Let's do bromine. Calcium's like not much more difficult than aluminum, so we'll do bromine. First up, how many electrons? Bromine, way down here, 35 electrons. This one will be quite a challenge. Same situation as earlier though. We're going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Take a deep breath. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. See how I put one electron in each of these boxes before I put a second one? 24, 25, 26, 27, 28. 4s is technically after 3d. So we're going to go 1, 2, and where does that leave us at? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and we need 31, 32, 33, 34, 35. May seem like a lot, but pretty easily done when you use the arrows. Now let's write it out. Oh, first, Lewis dot diagram, bromine. Last energy level, 1, 2, 3, 4, 5, 6, 7 valence electrons. Now let's write it out. 1s2. And once you get good at this, you'll realize they all start the same way until you end. 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, but technically 4s comes before that because the s sublevel is on the left-hand side and then the d. So we would say 4s, 2, 3d, 10, and then 4p6. The 3d and the 4s are very, very close to one another in energy-wise, but we still write 3 even though the d is in the 4th period. There's reasons for that, but we're not going to get into it in this class. AP or college chemistry, you probably will. And I said 4p6. That's supposed to be 4p5. Sorry about that. So using the orbital diagram makes it pretty easy to write the electron configuration. Let's look at electron configurations without the orbital diagram. Start with the easy one, lithium. We don't have the diagram. All we have to look at though is the number of electrons. Lithium is right here. The easiest way to do this, write the ending first. Second period, S subblock, first element. Now write everything else up to that point. So if we go back, we've got to do 1s, 2, and then 2s, 1. That covers the first period, and then second period, first element. Pretty simple. Lithium, that is. Look at, let's say, potassium. We'll skip sodium. Obviously, we're going to have the first 3 periods covered, so let's go ahead and write those. 1s, 2, 2s, 2, go across here, we're still in second period, 2, this is the P sublevel, 1, 2, 3, 4, 5, 6, 2p6, come back around, this is the S sublevel again, 3s, 2, because we're in the third period, straight across, we're back in the P sublevel, third period, 3p, we're going to cover all 6 of these, 3p6, scoot all the way back, S sublevel, 4th period, 4s, first element. 1. So that's what that would look like for potassium. Okay, let's try a couple of more and then I'll let you get at it. Let's do silicone first, and then we'll try germanium. Silicone, over here in the P sublevel, third period, so it's going to be 3P, 2. Put that up here in the corner, 3P. That's what we're going to end with. Now, we're going to cover 1s2, just like always. One S2, back in the S sublevel, 2S2. Go across P sublevel, second period, 1, 2, 3, 4, 5, 6, 2P6. Go back across, third period, S sublevel, 3S2. Jump all the way across, still in the third period. Now we're in the P sublevel, and remember we said 3P second element. So that would be our total electron configuration for silicone. Is it starting to make sense? Again, this is a tough concept, one of the toughest we meet all year, so we're just going to skim across it. We're not going to get into it too deep. Last question, germanium. Way over here. Everybody see that? 32 is the atomic number, so 32 electrons. Let's see how we're going to end. Fourth period, P sublevel. Remember, this big bunch of nonmetals is mainly called the P. And then 1, 2 elements, just below silicone. So first up, we're going to start off with 1s, 2. Because again, pretty much everything is going to cover that besides hydrogen and helium. Second period, S subblock, cover both of those. Jump across. Second period, P sublevel, covers all 6. Go back across, third period, S sublevel, covers both. Go across, still third period. We're in the P subblock. It's going to cover all 6. 1, 2, 3, 4, 5, 6. Go back across, fourth period, S sublevel, going to cover both. Now remember, this is where it's a little different. You get to the D sublevel now, but instead of the fourth period, even though you're in the fourth, you put 3. So 3D. And how many elements of those is that going to be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now back to the P orbital, but we go back to our period. So 4P, 1, 2. The only time that the number doesn't match the period is going to be in the D or the F sublevel, which like I said, we're not worried about F. We're just going to be talking about S, D, and P. So just remember, D is always one number behind the period. So if you're in period 4, you'll start with 3D. Period 5, 4D, 6, 5D, and so on. So that's our total electron configuration for germanium. Question 11 asks us, how would the electron configuration for an ion differ from its neutral atom? Well, what's an ion? It has what? More or less, big players in this chapter, electrons. I'm not worried about us writing out electron configurations for ions. Like I said, we're just going to skim through it. So I hope that helps. Again, I expect questions, and don't feel embarrassed or like you're the only one that has questions, because like I said, this is going to be, or this normally is one of the 2 to 3 hardest chapters of the book for the entire course. And it's especially hard when you're not sitting in front of me for 3 or 4 days straight and me working these out and helping you do so. So virtually makes it even more challenging. If you have any questions about it, let me know. Again, you advanced kids, you really need to understand this in order to move up to AP and then eventual college chemistry for those of you that go to college. Otherwise, there will be some questions on the quiz involving them. On-level students, you'll mainly have questions involving Lewis structures and Bohr diagrams. Until next time.